we're allowed to enter grades right now. They make us sort of like pause putting stuff in the grade book so that I guess it messes up printing out the progress reports. I don't know. So I can't alter anything right now. If I sent out that retest, you were supposed to have done the retest by 11:59 last night. If you missed it, this is all the way back from the 15th, quite some time ago. All right. I do not want to run out of time, and I'll need to make sure that everybody knows if they're missing something, what they're missing. Where is the most likely place for active volcanoes to form? Yes, there are multiple places, but the most likely place where? Ring of Fire. Okay, what is the Ring of Fire though? What's happening? Okay, ocean. Well, it's part of it. What do we call that kind of interaction? Yes, you're right. It is the Ring of Fire. There's more than one section like that, but. A what? There we go. It's a subduction zone. So that means what two types of plates are coming together? It's convergent, okay, but what two types of plates are coming together? Continental and oceanic. That is correct. Now, there are other places where volcanoes can form, okay, but that is the most common place to find deep, active volcanoes. And yes, it is called the Ring of Fire. You were correct. I'm going to get with my remote staging. There it is. Let's see. If they appear in the middle of a continental plate, or an oceanic plate for that matter, because it can happen in both, what has to be present for a volcano to form? A hot spot. That is exactly correct. And there are both oceanic and continental hotspots.
What about lava?
What about lava?
What was already out of the volcano?
Well, I mean,
magma.
Magma, and then once it comes out, it's lava. So yeah, if it's an active volcano, it's going to have both of those. Is it inside the earth, or is it actually come outside of the earth? So you have some type of rift in Earth. Okay, it could be like an oceanic ridge where you don't normally see it because it's constantly being pulled by the ocean. Okay? Or it can actually be coming up with what you think of as a volcano. These nice steep slopes, and then it has sort of like the opening in the typical top of what you think of if you would draw a volcano. Not all volcanoes look like that. Only certain volcanoes have what you would consider a classic volcano shape, but they have to have magma. Okay, that's when it's inside. Eventually, it forces its way out as lava. But there's also what we call bombs, huge rock fragments that have gases trapped inside, and they literally can explode, which is why they're called volcanic bombs. And a whole bunch of toxic, hot greenhouse gases, where if you breathe them, you will die. Whether they incinerate your lungs or it's just toxic and you die from the poisoning. Once the magma does break the surface, whether it be what you think of as the surface into air or underneath the ocean is still breaking the surface, it's just underwater, it's still left the crust. That's when it becomes lava. What makes the volcano a nice and quiet one, like Mauna Kea and Mauna Loa and Kilauea, or one that literally goes boom, like Pinatubo or Krakatoa or St. Helens, has to do with the type of magma that's escaping the volcano. How volatile is it? Yes, there's a couple other things that are in play, but your primary controlling mechanism on, is it a nice, peaceful volcano, still lava, still kill you, or is it one that's literally going to explode and spew out a pyroclastic cloud? Is controlled by, is it basaltic, or is it granitic, or is it andesitic magma? And we haven't used those terms in a while. We did that when we did the rock cycle and igneous rocks. We had a specific section just on how magma controls the rock formation. Typical cross-section of what you think of as a volcano. This is what you see in your head. So you have some type of, now I'm so not used to this thing. You have a magma chamber, which would be down here at the bottom, and then you have the main avenue for it to go out. Now they can go off on the sides too and break the surface, and that's part of what made the entire face, the top and the side of St. Helens blow off, is it had these side shunts where there was a lot of pressure built up inside St. Helens. It had not exploded in over a century. Eventually, just like shaking up, you got something that has like a cork in it, and you shake it up, it's going to pop the top. And that's literally what happened with that mountain. This one shows volcanic bombs. That would be these things that are sort of flying off on the side. Those things can explode, especially if they hit water. They don't always have pyroclastic flows. That would be these gases and the ash that's going to follow along the side of the volcano, and they're going to go from high elevation to low elevation. The same thing with the toxic gases. Unfortunately, some of the toxic gases you can't see, and you can't smell, you can't taste, but you breathe it, and they will kill you. Most volcanoes do form along plate boundaries at specifically subduction zones. You have one plate sinking underneath another plate. Now, in a subduction zone, the oceanic, which is more dense, is going underneath the continental, which is more dense, going deeper into the into the oceanic crust, down into the mantle, and it allows that to raise up. Eventually, it gets high enough, it breaks the surface of the water, and you have things like, well, Hawaii is not a subduction zone. Hawaii is a hot spot. But eventually you have the volcanic top break the surface of the water. Hawaii is not the only hot spot. We talked about Iceland. In fact, we watched a documentary on it. The Galapagos Islands are like Iceland. They're trapped inside an oceanic ridge. Normally, a hot spot doesn't move. The plate moves over top of it, and as the islands move across, the ones that are further away from the hot spot, those are the older ones. The ones that's sitting on top of the hot spot, those are the youngest ones. Iceland is an exception, and the Galapagos Islands are an exception because their hot spot is actually trapped within the ridge, and it goes with the ridge. We mentioned the Canary Islands. They're off the coast of Africa. They're on our side of Africa. And you can also find them where you have diverging plates. And so at the bottom of the ocean, at the oceanic ridges, where they are splitting apart, you're not going to normally see it. Iceland and Galapagos are an exception. You still have volcanic activity down there. It's just not what you think of as a classic volcano. The picture that I had on the previous slide. Maybe my heater will decide to be better today. Finally wore something warm, now it's working. Go figure. This is the Ring of Fire. The Ring of Fire goes around the Pacific Plate. Okay, smack dab in the middle of the Pacific Plate, there's Hawaii right there. Okay, Hawaii is moving west. Eventually, Hawaii will slam into somewhere on the East Asian coast. I don't know if it's going to be Japan, I don't know if it's going to be China, but it's heading that way. And over enough millions and millions of years, it will actually become part of that continental coast. That's part of what lifted up the Rockies for us. A different island chain came along the Pacific Island, but hit us over here on this side. So where the Ring of Fire is, it circles the Pacific Plate. It is where the Pacific Plate is subducting underneath a different continental plate, whether it be the Eurasian Plate on the west side of it, North American Plate where we are, South American Plate where the Andes are. What makes them go boom? Not all volcanoes go boom. There are certain things that are present within the magma that are more indicative of a violent explosion, such as St. Helens and Pinatubo and Krakatoa. The biggest thing is if there's water vapor that's trapped within the magma itself. And we know once the pressure is released, that water tries to expand, it starts to boil, and it literally makes that bomb explode. Not like a nuclear bomb, a volcanic bomb. If the gases, including water vapor and carbon dioxide, are trapped, also sulfur dioxide gas, that's the stinky stuff that's toxic and causes acid rain. They also cause larger explosions. If there's high pressure, which is the next one, that causes them to explode more violently. If there's low pressure, it's a calmer volcano, like the Hawaiian volcanoes. I mean, they're constantly erupting. Kilauea has been erupting nonstop since 1983. It's just a thin lava. It doesn't have all these other trapped gases and water vapor stuck in it, and it's almost pretty as long as it, doesn't touch you and kill you. Very fast moving, very thin lava is not explosive with those particular types of volcanic mountains. It's essentially what they are, volcanic islands. Let me double check on that real quick what you guys are. Yeah, please. I went back and the 14th, when I had that meeting in the library all day, I finally, when I checked the attendance, I went back and fixed it. So if you were marked absent, for those of you that were remote, that should be fixed now from the 14th. I had to wait for the front office to put the substitutes attendance in. I don't see anybody else new. Let me go back here. I gotta find the right page. I am in the process of building the digital review, the Kahoot review for you guys for the test on Friday. Like I said, for those of you that are night owls and you're up at midnight, when it becomes Friday and you want to take the test at midnight, it'll open at midnight.
All right.
Yep. For those of you that, I'm not telling you to stay up till midnight, but some of you just, for whatever reason, you're night owls. And if you want to take care of that 30-question test, then you don't have anything else for me over the weekend. But it is on y'all to take that 30-question test once it's open. Types of magma. The more gentle eruptions are going to be made from basalt. That is deeper magma from the earth. It is hotter. Things that are hotter are more viscous. No, they're less viscous. I just said that backwards, which means that they're thinner. Granitic and andesitic, andesitic is sort of halfway in between. It's thicker and it traps more gases, including water vapor. Those are the types that tend to be extremely explosive. Like I said, all lava can kill you, but your thinner magma tends to be a more gentle eruption. Your thicker magma tends to be a much more violent eruption. We've mentioned pyroclastic flows before when we were doing igneous. It's just been some time. Plus, I have 2 students that did not take the first semester of Earth Space, and they don't understand any of these words because they didn't have them. Pyroclastic flows are when massive amounts of trapped gases and ash, the very, very, very fine particle ash, where if you breathe it, it can turn to concrete inside your lungs, comes rolling down the side of the mountain. They can go more than 100 miles an hour, depending on how steep the mountain face was, and then carry the ash far distances, bury entire towns in multiple feet of ash. And the gases that come out, things like sulfur dioxide gas, hydrogen sulfide gas, carbon dioxide, carbon monoxide, if you breathe them, you will die. Even if there's still oxygen in the air, there are certain gases that your blood actually prefers over oxygen gas, like carbon monoxide. Which is why you don't run a generator inside your house. Specifically, basaltic lava productions. We've talked about lava pillows before. They're not soft, but they're rounded, pillow-looking shapes that normally form at the bottom of the ocean when you're having rifting going on. Okay, I had to look these up. Actually called my friend Hawaii. I said, I don't know how to pronounce this right, and you're Hawaiian, so pronounce it for me. That is called pahoehoe, is how that is pronounced. It has a rope-like structure. Now, this first one is called pahoehoe lava. You can see like bands in it, if you will. If that particular type of lava, because this is basaltic, a lot of the words that we're about to take a look at are Hawaiian, and they pronounce every single dang letter that they show in a word. That same type of lava, if it's going cooler, then it doesn't have that rope-like structure, and that is literally pronounced ah. I don't know what it means, but that's how it's pronounced. I have to ask him. But these are basaltic, these are Hawaiian terms. They are from Hawaiian. Now, they don't call them Mount Kia or Mount Lua. The Hawaiians use, instead of mount, their term for mount is Mana, M-A-U-N-A. but it means the same thing. It's just a Hawaiian one. Where you can find basaltic volcanic lava, any of the Hawaiian ones. So Kilauea, there should be a comma. No. Mauna Loa, Mauna Kea. I didn't put Kea on there. Iceland is basaltic. The ones that we listened about on the documentary were Hekla and Laki, extremely destructive eruptions that changed global climate. There are a few others, but we don't have enough time to talk about every single volcano on this planet. We'll be mentioning the ones that you most likely have heard before. And this particular eruption that's being shown, they'll shoot very, very high in the air, but you're not going to have the entire top of the volcano blow off. That was a really huge bird that just flew past a little bit. Like you did with St. Helens. And Krakatoa was so explosive, it had 3 volcanic peaks, 2 of them completely and totally are gone. Like they're not even there anymore. And then the largest one, most of it just disappeared. There was just a little bit left above the surface of the water, but that one's being built back up. So it'll probably go boom again. That's the one we're going to take a look at tomorrow. Right, granitic volcanoes. Katmai. Some of these I do give you some information on not only when did they erupt, but how many people did they kill, how destructive were they. Yellowstone is the one that you probably are the most familiar with. I have visited it. It is a very interesting place. You are literally walking inside the caldera of the volcano itself. What happens with the caldera is when enough magma has been spit out, there's a void. Well, it collapses underneath its own gravitational pull and it creates a depression or a caldera. And there is a lake called Yellowstone Lake at the center of it. I'm going to show you a map of where the caldera is, and then we're going to take a look at where the immediate kill zone is, where the primary ash cloud is, and where the secondary ash cloud is, which is subject to conditions on the planet, subject to where the winds are blowing and how monstrous this thing does explode when it does again. Yellowstone has an eruptive cycle of approximately every 600,000 years. It has repeatedly blown up. We can see where the actual explosions have happened as the North American plate has moved across this hotspot. The last time it exploded, it's 40,000 years overdue, 640,000 years ago. And then this big thing down here, if instead of that thing exploding in a rural, basically nothing was there, just animals, 640,000 years ago, if it would have been in a metropolitan type area, like let's just say New York City. So you put Yellowstone in New York State, and it does the same kind of eruption as it did 640,000 years ago. And you've got over a dozen feet of ash through the entire state of New York. Next state over, Pennsylvania on the east coast, well, southeast. It's not really on the east coast of Pennsylvania. Pennsylvania doesn't really have a coast. The eastern part of the state, southeastern part of the state, you'd have at least a foot of ash, and you wouldn't see the sun for at least, let's see, that would be 60 hours translates to 2 to 3 days. You would hear the explosion, not necessarily this far, but all the way down to Atlanta. But we would still have problems with the noxious fumes that came out of that volcano, primarily because of the way that, well, I'm more worried about that with the way the jet stream is with where Yellowstone is located now. That would be if it was located in New York State, but we would still get it. It would be a worldwide thing. Yes, I'm gonna have to recommend you try A-Hall because people are continuously messing up the bathrooms and they keep locking them down. All right, this is a map of where Yellowstone is. You've got Wyoming, Montana's above it. I believe Utah is below it. I don't know my geography very well, but this outline, this is the caldera itself. There have been other explosions. I didn't pull the one that showed you how it's pockmarked And as you go further away to the southwest, you go back in time. The Yellowstone Lake is right here. And the bottom of Yellowstone Lake is actually rising, which is a horrible sign. That means that the magma is starting to swell up underneath the lake. It actually lifted a boat that had sunk for a short period of time. Right before my husband and I went and visited it, and we were like, I hope it doesn't explode while we're here. To put it in perspective, the dark one, you will instantly die. Like, you're not going to survive. You might survive for a short period of time as your lungs are turning into concrete, or you're breathing these noxious fumes, you try to hold your breath, or maybe your lungs incinerated and you had just a little bit of oxygen still in your blood before you're dead. But that very, very center one, right here. Now this is subject to change, because if it is a massive, everything is going to be exponentially larger. But that dark red, if you're living there, you're going to die. Okay. No pun intended. It probably will be, right? The primary ash zone, this is where you're going to be covered in up to a dozen feet of ash, if not more. Once again, it depends on how much this thing pumps out once it finally goes. It may not be a cataclysmic eruption. It might be one of the smaller ones.
Up there. I thought it was up. It was like.
No, Yellowstone is where Wyoming, Montana, Utah, and Idaho all come together. Like, the mouth of the caldera stretches into 4 states. That's why if you ever visit it, that's why there's so many geysers and hot springs and the mud pots, all the different smells and the sounds. Yellowstone is actually really interesting, as long as it doesn't blow up while you're standing in the mouth of a volcano. The secondary ash zone, you're still going to get quite a bit of ash, but it's nowhere near as bad. Now, like I said, we're not that far outside of that ash zone. It depends on how strong the winds are blowing, which way they're going, and how strong this volcano actually is once it finally decides to open its top again. Like I said, it is overdue. And I'm not trying to be like, oh, we're all going to die from Yellowstone explosion. But it can happen. All right, andesitic, Mount Pelée. This one killed 29,000 people. In this century, this is the most deadly of any volcanic eruption that has happened. Now, it's not the deadliest one that's ever happened, but it's not really this century anymore. It'll be last century, because now we're in the century after that. So I need to change the way that that's written to the 20th century. This one in the Philippines, it's extremely active. It blows up all the dang time. The last one in 1814, this is 2 centuries ago now, killed 1,600 people. So Mount Pelée, of recent time, is the most dangerous one. That tsunami that wiped out almost 300,000 people in the 2004 Indonesian collapse, that wasn't a volcano. That was an earthquake. Of the most recent natural catastrophes, that has got to be number one. It was like 230,000 people that either drowned or just were never recovered. The ocean never brought their bodies back on the shore. Y'all were probably babies when that happened. That was in 2004, the day after Christmas. It's horrible. Yeah, I was like, I could show you footage of it, but you see like bodies, like dead bodies. No, I don't think I'm allowed to show stuff like that. It'd be considered insensitive.
You said they're scared. We watch videos in the hall.
I could say that they're scarecrows. There goes another scarecrow. Okay.
Well, or no, we could just say they're all pedophiles.
Oh my gosh. Hayden, stop.
When I was in eighth grade, what you do? We were throwing dead bodies in
That was fun.
Yeah, but that's
that was hot.
been some y'all stop it. All right, we got 3 major shapes of volcanoes. Shield volcanoes. These tend to be your gentler volcanoes. These also tend to be your largest ones. The problem is a lot of them are covered by ocean, so you can't see the bulk of the volcanic islands, which is the case of the Hawaiian Islands and the Canary Islands. I can't remember if there's another one here. I have to check the notes. But these particular mountains are the largest of them all, the tallest of them all. It's just like I said, in the case of the Hawaiian Islands, you cannot see most of them. They're underwater. You have continual layers of basaltic lava that's nice and thin, and it literally builds the island up. You get black sandy beaches a lot because the basaltic rock that has been chewed up by the ocean. And there's others besides this, but the Hawaiian Islands are going to be the ones that, if you've heard of any, probably the most common. All right, Mauna Loa is, I should have had Mauna Loa here twice. This is Mount Kilauea. Okay, this is the largest, this is the main island. Hawaiian Island, the big one, the most recent one, which means it is the youngest of all of the Hawaiian Islands. As you go west through the Hawaiian chain, they're going back in time. They were formed previously. So I think it's Oahu's older. I want to know all my Hawaiian islands. And then there's Hawaii, which is older. There's Lahui. No, Lahui's the name of the town. There's a little one at the very, very, very end that unless you basically were born on the islands, it's off limits. They don't let tourists go there. Way, way, way out on the west part of the Hawaiian Island chain.
This is all smooth and for a field trip.
Yeah. What if you get caught?
That's a
They
good
throw you in the
question. Like,
lava.
it's like you don't go there.
It's
You just
kinda-
don't. You don't. I remember that when I visited back in 2008, I think it was. You don't get to go there. Like, planes don't take you there. Boats don't, like, it's like almost like a Gilligan's Island kind of thing, but Hawaii version. Like, you don't get there. You just don't.
It's not bridge.
You can swim, I bet.
All right. So anyways, yes. Kilauea has been erupting nonstop since 1983. No, shh. There is another type of volcanic island called a cinder cone. That is pronounced Pu'u'o'o.
Uh-oh.
Pu'u'o'o is how that, but so it's an extension of Kilauea. We haven't gotten to a cinder volcano. Speaking of which, cinder cone volcanoes. These have more explosive eruptions. These have more granitic lava. Remember, the basaltic is the thinner, is like the calmer type. The granitic and the andesitic is the thicker, has more trapped gases, more trapped water, tends to be much more explosive. Does not necessarily mean the entire top of the volcanic mountain is going to be blown off, but it can. That actually happens more with what we call stratovolcanoes, which should be the next one that we get to. With granitic lava, when it cools, the layers are called tephra. That's just the term for it. Basaltic lava does not do that. But cinder cones, they're the smallest of all the volcanoes. So your shield volcanoes are your largest. Your cinder cones are going to be your smallest. And I'm going to show you a cinder cone.
I could fit you in the pocket trees.
No, not like it's that tiny. They're still big. It's just compared to each other, it's the smallest of the three.
Start shooting lava.
It does shoot lava out at you. The one that I show you in Mexico, we still have a bit to get through. Like I said,
What if meteors make the volcano?
no, meteors don't make the volcanoes. The volcanoes are from the earth itself coming up. This particular one in Mexico, this is a cinder cone. So you can see with the basaltic one, the one that I showed you with the previous ones, they were shooting up in more of like a straight line. In a cinder cone, it's almost more of like, you know, like when you have the sparkler fountains with 4th of July, that's more of what a cinder cone looks like when the lava is coming. Of course, that would be at
You ever
night.
put one of those on a bottle rocket?
No. Next one, deposit volcanoes, or what we normally call them stratovolcanoes. These are huge, not necessarily height-wise, especially with the Hawaiian Islands because you go so much further down into the ocean, just massive size. St. Helens is an example of a stratovolcano. You've got the lava flows, but you've also got rocks that are embedded. And these normally have a lot of pressure that builds up before they finally explode. So when they do explode, it releases all that energy at once. And these are the ones that tend to blow their sides off. So you've got a combination. I need to double check my mail. I just heard a thing to make sure. I think that was just my email I heard. Oh yeah, kid's getting in trouble again. I don't see anybody. So who's not here? Alex is here, Otis is here, Caden is here, Carol, Cameron, Dylan, Jimmy. Let's see who is here. We have a couple of stratovolcanoes or composites, the same thing. It's stuff we're always heard people call them stratovolcanoes. First one we're going to talk about is St. Helens. It's erupted a few times, but that last monstrous eruption, which I think I showed you guys a video of it exploding. If not, I'm going to show you a before and after, side by side, of what it looked like, how much of the actual mountain blew off. This was one of the most dangerous ones that has happened on our soil, at least in the continental United States. Alaska's had some bad ones too, but sometimes they don't count the Alaskan and the Hawaiian ones with the rest of the continental United States. Killed 57 people and wiped out all different kinds of wildlife. Now, St. Helens is in the Cascades in Washington State. So it's the northwestern part of the continental Rocky Mountain chain, specifically the Cascade version, the upper version. Vesuvius, you should have heard of. Vesuvius has blown up more times after this, but the Pompeii explosion was in 79. Not everybody died in Pompeii. Not everybody, but a large amount of people were suffocated by the noxious fumes and then were covered with the ash, and it preserved them, it mummified them. And most of them look like they're sort of like we're in the process of running and then just lay down, because that's exactly what was happening. Pinatubo blew up not that long ago. Killed quite a few people. But what Pinatubo did is it put so much ash up into the Earth's atmosphere, the upper atmosphere, not like the thermosphere or anything, but above the troposphere, up, goodness, computer, up into the stratosphere, circled the globe, and it reduced the temperature planet-wide. It caused horrible floods. I remember those floods on the Mississippi River. All the levees were free and broken. It caused so much destruction. I was in high school when that happened. Also had a horrible drought in Africa. Now this was, let's see, somewhere between 1.5 and 2 years after the eruption. So volcanic ash can have all different kinds of cataclysmic effects in other places of the world. He said it affected us and affected in Africa. And a lot of times volcanic eruptions trigger a cool down. Lots and lots and lots of rain, lots of snow. I was already in Texas at the time, so we didn't experience the horrible snow that the Northeast did. All right, this is what St. Helens looked like before and after. So this is a stratovolcano. And you can see if like this entire section, including the side, literally was blown off. And the one on the right, you can see by the way that the snow has formed in the valleys, you can see where the lava and the pyroclastic flows went. Anything that was down in this area was wiped out. Now, most people aren't dumb enough to live right at the base of a volcano. The thing was, The thing with this guy is it had not erupted in over 100 years, and people thought that it just wasn't going to do its thing anymore until it did in 1980. There was warning, like 2.5 months before the actual explosion, there was a bunch of seismic activity. So
What is that?
that is St. Helens.
I don't know, like, seismic activity.
Like earthquakes and tremors, and they had some smoking and gases. Like there are volcanologists that actually have machines to record the data towards the top of these things.
You're telling me they had time to go?
Well, they had basically a 2-month warning. This thing was putting out activity in March. It actually exploded in May.
Was there people there?
Oh yeah, well, it killed 57 people.
How are they still there?
That's a good question.
You're stupid.
Krakatoa.
Earthquake shot.
This is the one that we're going to watch about tomorrow. Krakatoa is Indonesian. Now, in 1883, there were 3 volcanic peaks that made up Krakatoa. Now, nobody lived on Krakatoa. Like, they were that down. Okay, but when this thing blew up, the 2 smaller peaks disappeared. Like gone. Like, they blew up. The large one for Krakatoa, the bulk of it exploded. There was a
Sorry.
there was a little bit left over, and that's actually rebuilding, and it's not called Krakatoa anymore, it's called Krakatau. But it's literally the offspring of Krakatoa. What killed people with Krakatoa is because it put out a huge tsunami that took out thousands and thousands and thousands of people, because when it comes to Indonesia, most of your villages, your fishing villages, are close to the dang ocean. They couldn't get out of the way in time. They drowned. The dust from this thing affected the temperature for 5 years. And like I said, with your big explosions, such as Krakatoa, it triggers global cooling. We just have 3 different types of eruption, and we're through, and I will go through and tell you if things are missing.
Is it possible for like a big enough explosion, like from a volcano or something like that, to like move the Earth's orbit?
If it's a big enough earthquake, yeah, and it can, but I think that's one of the reasons why we had to have a reverse leap second. We had, like, our timing is off, our orbit's off, our timing's off right now by a leap second, but in the opposite way it normally is.
Wait, so that was caused by an earthquake?
Normally, yes.
So we need another earthquake to put ourselves back, correct?
Well, what if it makes it worse? Right, 3 types of eruption. If the gases escape easily, it's considered gentle. That's normally basaltic. Those would be your Hawaiian Islands. The lava is normally quickly moving. If you have gas buildup and you have what are called lava bombs, you've got thick, normally granitic, sometimes andesitic magma. This is more explosive. It's not the most explosive. But the gentlest one would be basaltic, where the gases escape easily. There's no pressure buildup. It's the pressure buildup of the gases that causes the explosion. The gas heats up, it starts to expand, and literally, boom, that's why they're called lava bombs.
Wow.
And then the last one, oh, he's still typing.
They're like the worst bath bombs.
No, it's not like a bath bomb, Caden.
What do you call an Islamic in bath?
Oh no, stop it. Last one. If you have lots of buildup of gases, this is the one that likes to pop at the top. This is what happened to St. Helens in 1980. In fact, it wasn't just the top of the volcano, it was the entire side of the volcanic mountain. Now, to my knowledge, well, St. Helens did something else. It was either 82 or 84, but it was nothing like the explosion in 80. I'm sure it's going to explode again eventually. Let me double check stuff.
Islamic people ever gave the kids wrong.
Oh, stop it. Caden. Yeah, let me, whoops,
Over there on the-
let me stop this. Let me stop that.